Hi guys, how's it going? Today we'll be going over evaluating limits. And so, we know that limits is essentially the lifeblood of calculus. It is what allows you to take a derivative at a certain point, and really it just builds off from there. In today's video we'll be going over some different ways to take a limit. We'll be going over L'Hopital's rule, and really just having fun with a little bit of algebra here and there to evaluate a limit. So without further ado, let's get started. So the first thing I see when I see this limit is that there's an x in every single term, and I look at the bottom and I see it can beat it. You can factor this out. And so when I rewrite this, I can rewrite this as limit. Always rewrite your limit. Factor out an x squared minus 7x plus 10 all over, if we factor this, we get x plus 3 and x minus 2. Okay, and well, we see that we can maybe factor this out. 10 has 2 and 5 and 10 and 1, and if we add 2 and 5 together, we can get a coefficient of 7, or rather subtract the negative of both of them and we get negative 7. And so if we continue to factor this, limit as x approaches 2, x outside, x minus 2, and then some x minus 5, all over x plus 3, x plus, minus 2. Now, if we had gotten the question like this in the first place, we can see why, if we had plugged in 2, it would not have worked straight up, instead of just going through the problem, plugging in 2 and seeing through that way. But since we have it all factored out, we can see that since there's a coefficient right here of x minus 2, a factor here up top and bottom of x minus 2, this limit would have been 0 over 0, and therefore we could have used L'Hopital to evaluate this limit. But rather, we can do it this way. So we cancel out both x minus 2 on top and bottom. Let x be 2. So 2 times 2 minus 3 is negative 6 over 2 plus 3 is 5, and we get our limit. Okay. Now let's look at this problem right here. Now, here we can see that it's not going to be as easily factorable as the last one. And so this is when we look at, okay, what happens at x equals infinity? So you get infinity plus e to the infinities could be even larger infinity, so we're going to have x squared plus e squared, limit as x approaches infinity. Always write this out on an exam, show that you tested it out, is equal to infinity, okay? Or approaches, I should rather say. And we look at the bottom. Now that's going to be infinity minus infinity. We don't really know, but we know that e to the x is going to be pretty large, so it's also going to be infinity on the bottom. Limit as x approaches infinity of 2x minus e to the x is going to approach infinity as well. Rather negative infinity, but at one point infinity is just infinity. And so, because we wrote this out, and because we showed that both top and bottom will go out to infinity, we can write it out as equal to, have a little L'Hopital on top. And what L'Hopital's rule tells us means that we can take the derivative of top, so 2x plus, let's see, the derivative of 4e to the 2x is 4e to the 2x. Chain rule the 2x, we get 8 on the bottom. So we get 8e to the 2x on top, all over 2 minus e to the x. And that is what L'Hopital allows us to write. Make sure we never forget to rewrite limit. And so yeah, L'Hopital allows us to rewrite this limit as this. Sometimes it gets us anywhere. Let's see if it got us anywhere here. Well, let's see, 2x plus another infinity. So infinity plus another infinity, if you plug in infinity, is going to be infinity. This is going to approach infinity as well. Now let's look at the bottom. Maybe this, oh no, this could be another infinity, because limit as x approaches infinity, 2 minus e to the x is going to approach negative infinity, but at one point it still would be infinity over infinity. Therefore, we could use L'Hopital's rule one more time. So you're right, L'Hopital on top. Sometimes, depending on your teacher, depending on how strict they are, they can take off points for not writing L'Hopital. It really is circumstantial, but rather most of the time you should be writing this out on top of the equal sign to imply that you did something to the original limit. So limit x approaching infinity. Okay, so let's write out 2 plus another derivative here would be 2x. So the derivative of this would be 8e to the 2x. Chain roll the 2x down. We have 16e to 2x all over negative e to the x, because e to the x is derivative is just itself. Now we can see at this point in our derivation that no matter how many L'Hopital rules we're going to take, there's always going to be an e to the x on top and an e to the x on the bottom. So even if we take an infinite amount, they're still going to be at the same point up and down. So they're both going to go to infinity. So we got to find a way to change this a little bit. Well, we can rewrite this as right? You just put a negative here and move it up to the numerator. Now we don't have infinity times over infinity. Now we have something else completely entirely. So how about we distribute this to each side? So equals limit x approaches infinity, negative 2e to negative x minus 16e to the x. Okay, and so now we can evaluate this as x goes off to infinity, and so as x approaches infinity, right here, this term right here is going to approach 0, because it's essentially going to be, this term is going to be 1 over negative to the x, and so as e gets really large, this term right here will approach 0, and so when we plug it in right here, we get this term right here is going to approach infinity, and we're going to have a negative here. So we can say that this limit is going to approach negative infinity, and that would be our answer right there. Okay, so jumping into our last limit of the day, this one's going to be a little trickier, as you'll see later on. So let's just jump right into it. So first off, we see y approaches 0 from the right side, and we see a cosine in there. And then we have a 1 over y squared in the exponent, so that's already pretty scary. So this implies that since we have something to the exponent, and it looks like that exponent is going to be 1 over 0-ish, this is when my head's already going to L'Hopital a little bit. But first, we got to do some work. We got to tweak it a little bit to get it there. So what we want to do is express, let's take this and express it as a function. So x is equal to cosine of 2y all to the 1 over y squared. Now, to bring this exponent maybe a little down, right here we'll take the ln of both sides, and through logarithmic properties we can take this and put it as a coefficient. So 1 over y squared ln cosine of 2y. Okay, so now that we have pulled this out, now let's check limit as y approaches 0 from the right, ln of x is equal to ln of cosine of 2y over y squared. And if we plug in y top and bottom, we will get limit as y approaches 0 from the right of ln cosine of 2y approaches is 0. Sorry. And same thing for the bottom. And so here we will have a 0 over 0, and we will have to take L'Hopital. So let's move over here and let's write it out. So we'll take derivative top and bottom. So let's split this up a little bit so we give ourselves a little more room. Take the derivative of the top, we'll have, so we have to, this is just 3 chain rules, and if you look at it, ln, cosine, and then 2y. So we take the ln, the chain rule of the ln first, so it'll be 1 over cosine 2y times cosine, the derivative of cosine is negative sine, so negative sine 2y times 2. So 2, let's rewrite this just on top of this fraction, negative 2 sine 2y. Okay, and divided by, so divided by, this is going to be a little weird notation, but bear with me here for a sec. 2y. Okay, so kind of cleaned up a little bit. Let's rewrite this. This can be expressed as negative 2 tangent 2y. So as we cleaned it up, y approaches 0. Negative 2 tangent 2y over 2y. But we run into the same problem yet again. Limit as y approaches 0 from the right side of negative 2 tangent of 2y will be 0. And limit of y approaching 0 from the right side of 2y is going to be 0. So that means that we'll have to take one more LHospital. Sorry, and that should be there. I should be running correct notation, apologize. And so when you take the LHospital here, so limit as y approaches 0 from the right, and so when you take this derivative on top, we'll have a chain rule. So we'll have negative 2. Sorry, I should probably cancel this out in this term. And so we have a negative. We secant squared. Secant squared 2y, chain rule the 2 inside, so that's going to be 2 here, over 1. So finally now, we can evaluate this limit because there's no y in the bottom preventing us. And so when we plug in secant squared of 0, we will end up with 1 as secant squared, and this will equate negative 2. Now, I went over 3 very common types of problems that you will find really sometimes just use algebra, test out, can you factor some things out, can you tweak it a little bit, see if things can cancel out top and bottom, or in the exponent, because we know our determinants form are 0 over 0, infinity over infinity, and there are 0 to the 0, infinity to this infinity, all that. So we want to make sure that we're not taking a LHospital rule when we can't. So every time, write this out, and on the test as well, to show the teacher that you were looking for those individually. And then really just going through the derivation, going through the equations, and really just using LHospital. So I hope you learned something, and I hope you enjoyed it.